Hi, I'm Norman. These are my test corrections, and we'll start off with the third question on the multiple choice, which is the following. I couldn't actually get the image for this one to load, so I'll just type it out. Sorry, there's something in the way. I'll just type it out here. A projectile is fine. So this is the question. The answer choices are just a bunch of values like option A, which is like, sorry, I'll just draw it out because it's easier. Um, Answer option A, which is theta equals to inverse tan to the fourth, and like option B, which is theta equals inverse sine of the fourth, and option C, which is theta equals inverse cosine to the fourth. So like there's a few more answer options, but they're all just like similar to like this, which is like an inverse trig function and then a value here. Um, um, the correct way to approach this question is actually to just plug each of these values into the calculator and then see what you get. And then which means that the correct answer is actually A, which gives us 75 point, I believe it's like 75.9, like 5 something. So let's just say 76 degrees. And then what you do with this 76 degrees is you actually put 76 degrees into the height and the range equations. And what you'll find is as long as you use a velocity that is consistent within the height and range equations, then you'll actually get the same value at 76, which is why A is the correct answer, because you will get a value which makes the height and the range equal at the angle theta equals inverse tan to the fourth degrees, or 76 degrees. So moving on to the next question. The picture actually loaded this time. Question 4. You can see the question says that a spring gun fires 2 bullets on a flat horizontal surface at a fixed speed. The first bullet is launched at 30 degrees as the second one 60 degrees above the horizontal, and it asks for which of the following is true. Sorry. Um, so the correct way to approach this problem is to know that Vy is equal to Vx, and when that's incorrect. Vy1 is equal to Vy2 because on the horizontal plane, they're actually moving at the same on the horizontal axis. Oh, sorry. This should be x actually, unless you put y as your horizontal. Vx1 equals to Vx2, and on the horizontal plane, they're actually moving at the same speed. But since at the peak point, which is at the peak point, the Vx is equal to 0, and then what you find is that Vy of the angle that is less of at the smaller angle, which is 30 degrees, the Vy of 30 degrees projectile, I'll just write shorter, is always going to be greater than the Vy of the 60 degrees projectile, because the Vx at the top is always the same, and it is also equal to 0. Now moving on to the free response questions. The first problem would be problem 6, and it basically describes that a projectile is launched from the top of a cliff above level ground. At launch, the projectile is 50 meters above the base of the cliff and has a velocity of 75 meters per second at the angle 53 degrees with the horizontal. Air resistance is negligible, and like so on and so forth. So the first thing before we will attempt any of the first thing we would do before we attempt any of these questions is that we would actually find Vx and Vy. So we know that because like vectors, and we know the angle and we know the speed, we can just find Vx and Vy. You know that in the x direction you would use sine 53 degrees, which is the angle that it was originally launched, and for the y direction you would use cosine 53 degrees, and like, because they're like the same, right? And then putting this in the calculator, you would get 59 point, sorry, I'm copying on the wrong top. You would get 45.136 for this, and then you would get 59.898 for this. And we're going to keep these values in mind because we're going to use these to find the answers to the next questions. So for part A, it asks for us to calculate the total time from launch until the projectile hits the ground at point C. So I did this question wrong because I just used the time equation like right away, like the sine theta over g. Over g. This is like incorrect. What I should have done is I should have done delta y equals v naught yt minus 1, sorry, it's a bit messy, minus 1/2 g t squared. And the reason we can use this is because we have a delta y, which is 50 meters, actually negative 50 meters, and we have our value of Vy that we just calculated, and we have our value for gravity, obviously. And all we would actually need is our time. So putting in our values for this, delta y is negative 15 meters, because that's how like far down it dips. We would get V, and then we would plug in what we had for Vy. If you remember that, that's 59.898. And then for t, that's what we're solving for, so we don't plug that in yet. And then we get 1/2 gt squared. Gravity is obviously 9.8, and then like using that we could get 4.9 for 1/2 g, so just cancel that out. And then just going off of that, you can actually put 0 here, and you can just copy all of this down. 8t minus 4.9 t squared. And using this, you can just solve for t. I'll just write down the answer right away because using the calculator would take a bit, but it should be equal to 13.01 seconds, which is not what I got. So moving on to part C, for this question, I just sort of ran out of time because I took too long thinking about them, so I didn't really get to the opportunity to do them. So for part C, it asks for the velocity of the projectile at point A, and if no calculation is necessary, explain how you know the answer. For the velocity at point A, which is the peak of the this is supposed to be like the movement of the cannon, or the projectile that is launched out of the cannon. So at point A, we know that it's the peak of the sort of little curve, and we know that at the peak, the velocity in the horizontal direction, like in this direction, is actually equal to 0. And we also know the Vx is actually stays constant, and it's equal to 45.136 meters per second, which is like what we calculated earlier with our little thing that was like V sine 53 degrees, which is this. Since we know that the velocity in the horizontal direction is actually 0, then we don't need to do any calculations at all, and we can just use our value for Vx, which is 45.136 meters per second, because there's no vertical component, so like you don't really need to do any calculations. That's just the answer, which is like pretty simple. For the next question, we want to know the velocity of the projectile at point B, which is sort of like, hold on a second. So this is negative 50 meters. 50 meters, I guess, over here. This little part is 50 meters. I'm just redrawing the diagram. And then this is where the projectile is launched. And this is point B. And this is A, and this is like C. So, you don't really need to do any calculations for this either, because we know that, delta y, so let's just put the problem like this. This is the y-axis, and this is 0. So you know that from the origin, let's just call it O, from O to B, from O to B, delta y is actually equal to 0, because the change in the vertical displacement is essentially 0, right? So when we know this, we also know that the original velocity is 75 meters per second. We actually know that the value here is also equal to 75 meters per second, and no calculation is really necessary, because we know that like delta y is equal to 0, and like it's equal to like the initial, basically. That's about it. Moving on to part D, it's asking for the velocity of the projectile, part E, the velocity of the projectile at point C, and this one actually requires calculation. So, essentially we want to so the way that we want to approach this question is that we want to use our little like thing that we got from the previous question. I believe it was part B. We actually managed to get like something that would look like this, right? And this is obviously our Vy. And this will actually just bring us to our answer, because essentially like what we got was that, oh shoot, actually this was actually Vx in our previous calculation, which is actually 45. So in our old calculation, this was actually 45, but we're just replacing it with 59 here, and then all of the rest stays the same because these two are constants, and this is 0 now because we're calculating the time that it takes to get from like here to here. So sorry. And then so the delta y is actually equal to 0 as well. And then when we put 45 point, whatever value that was, I think it was 45.136 for Vx. For Vy, which is 59.894, sorry about that. We'd actually get that t for this portion is actually equal to 12. 2, 2, 4.